The entire recreational vehicle property is treated like a building or structure for the purpose of electrical service. Article 551.7 of the 2005 National Electrical Code states recreational vehicle park electrical service and distribution systems shall be considered outside branch circuits or feeders, as applicable, and shall be subject to the requirements of Part 3 of this article. This signifies the service entrance for the park must adhere to the mandates of Article 230 for services in buildings or structures. The service point marks the division where the serving utility's responsibility ends and the utilization phase begins. The service equipment and disconnecting means must be situated at the point where the service enters the park property. This is the designated spot where the utility installs the meter, granting the park owner control over the electrical system. Per service point, the electrical installation is classified as the utilization segment of the system. The park owner bears the onus of designing and installing the electrical system beyond the service point, ensuring compliance with the National Electrical Code's stipulations. The authority having jurisdiction, known as the AHJ, is entrusted with the responsibility of approving the electrical installation. The AHJ has the authority to inspect the electrical system, verifying its adherence to the National Electrical Code standards. Upon satisfactory assessment and approval, the AHJ issues a certificate of occupancy. The service for a recreational vehicle park mirrors the service requirements for a building or structure. The service point defines the transition between the serving utilities domain and the initiation of utilization. The service equipment and disconnecting means must be precisely positioned at the service point. The park owner is accountable for the design and installation of the electrical system extending beyond the service point, strictly adhering to the National Electrical Code's regulations. The AHJ assumes the role of approving the electrical installation. Let's delve deeper into the intricacies of recreational vehicle park electrical systems. Firstly, understanding the definition of a recreational vehicle park is crucial. Typically, it is an area designed to accommodate recreational vehicles, providing amenities such as electrical hookups, water, and sewage disposal. Secondly, the National Electrical Code, or NEC, serves as the foundational document governing electrical installations in these parks. Article 551, specifically, addresses the unique requirements for recreational vehicles and recreational vehicle parks. One key aspect is the concept of the service point, which, as previously mentioned, delineates the responsibility between the utility company and the park owner. It is the location where the utility's service conductors connect to the park's electrical system. From this point onward, the park owner assumes responsibility for the distribution and maintenance of the electrical infrastructure within the park. Another critical element is the service equipment, which includes the main disconnect, overcurrent protection devices like circuit breakers or fuses, and metering equipment. This equipment must be readily accessible and located at or near the service point. The purpose of the main disconnect is to provide a means to quickly de-energize the entire electrical system in case of an emergency or for maintenance purposes. The overcurrent protection devices safeguard the system from overloads and short circuits, preventing potential fires or equipment damage. Metering equipment accurately measures the electrical consumption of the park, allowing the utility company to bill the park owner accordingly. The distribution system within the recreational vehicle park consists of feeders and branch circuits. Feeders are the main conductors that carry electricity from the service equipment to various subpoles or distribution points within the park. Branch circuits extend from these subpoles to individual recreational vehicle sites, providing power for appliances, lighting, and other electrical devices. The National Electrical Code specifies the minimum size and ampacity of conductors used in both feeders and branch circuits based on the anticipated load. It also dictates the types of wiring methods that are permitted, such as underground wiring or overhead wiring. Grounding is an essential safety feature of any electrical system, and recreational vehicle parks are no exception. The grounding system provides a low-impedance path for fault currents to return to the source, tripping overcurrent protection devices and minimizing the risk of electrical shock. The National Electrical Code mandates the installation of a grounding electrode system, which typically consists of ground rods, ground plates, or connections to a metallic water pipe. In addition to the grounding electrode system, the National Electrical Code also requires the bonding of all metallic enclosures, such as equipment cabinets, junction boxes, and conduit, to ensure electrical continuity and minimize the potential for voltage differences. Recreational vehicle sites must be equipped with ground fault circuit interrupters, known as GFCIs, to protect occupants from electrical shock hazards. GFCIs are designed to detect even small amounts of current leakage to ground and quickly de-energize the circuit, preventing potentially fatal shocks. The National Electrical Code requires GFCIs to be installed in all 15 amps and 20 amps, 120 volts receptacles that are located outdoors or in damp locations. Furthermore, the National Electrical Code addresses the specific requirements for recreational vehicle supply equipment, which includes the receptacles and power outlets provided at each recreational vehicle site. These receptacles must be of the correct voltage and amperage rating to accommodate the electrical loads of recreational vehicles. They must also be protected from the weather and physical damage. The authority having jurisdiction, or ORJ, plays a crucial role in ensuring that recreational vehicle park electrical installations comply with the National Electrical Code. The AHA is typically a local building inspector or electrical inspector who is responsible for reviewing plans, conducting inspections, and issuing permits. Before any electrical work can begin in a recreational vehicle park, the park owner must submit plans to the AHA for review and approval. The plans must show the location of the service equipment, feeders, branch circuits, and other electrical components. Once the plans are approved, the park owner can obtain an electrical permit and begin the installation. Throughout the installation process, the AHA will conduct inspections to ensure that the work is being performed in accordance with the National Electrical Code. If any violations are found, the AHA will issue a notice of violation and require the park owner to correct the deficiencies. Once the installation is complete, the AHA will conduct a final inspection and issue a certificate of occupancy indicating that the electrical system is safe and code compliant. In addition to the National Electrical Code, there may be other local codes or regulations that apply to recreational vehicle park electrical installations. It is essential for park owners to be aware of these requirements and to ensure that their electrical systems comply with all applicable codes. Proper maintenance of the electrical system is crucial to ensure its continued safe and reliable operation. Park owners should conduct regular inspections of the electrical equipment, looking for signs of damage, corrosion, or overheating. They should also test GFCIs periodically to ensure that they are functioning properly. Any repairs or replacement should be performed by a qualified electrician. When planning a new recreational vehicle park or creating an existing one, it is essential to consider the electrical needs of the recreational vehicles that will be using the park. Recreational vehicles can draw significant amounts of power, especially when multiple appliances and air conditioners are running simultaneously. Insufficient electrical capacity can lead to overloaded circuits, voltage drops, and equipment damage. The National Electrical Code provides guidelines for calculating the electrical load requirements of recreational vehicle parks, taking into account the number of sites, the types of recreational vehicles expected, and the anticipated usage patterns. Park owners should work with a qualified electrical engineer to design an electrical system that can adequately meet the needs of their customers. Surge protection is another important consideration for recreational vehicle park electrical systems. Surges can damage sensitive electronic equipment in recreational vehicles, such as televisions, computers, and appliances. Surge protective devices, known as SPD, can be installed at the service equipment and at individual recreational vehicle sites to protect against surges caused by lightning, utility switching, or other events. The National Electrical Code recommends the use of SPD in recreational vehicle parks. In conclusion, recreational vehicle park electrical systems are complex and require careful planning, installation, and maintenance. By adhering to the National Electrical Code and other applicable codes, park owners can ensure the safety and reliability of their electrical systems and provide a positive experience for their customers. Remember to consult with qualified electricians and electrical engineers to ensure that your recreational vehicle park electrical system meets all applicable requirements.